What happens when your client doesn't support LLM sampling, but your tool needs to generate text? You don't have to leave users stranded with errors. We'll implement a fallback system that first tries the client's LLM, then seamlessly switches to a server-side handler when needed. You'll see how to configure FastMCP with an OpenAI-based fallback, ensuring sampling requests always succeed, no matter what the client supports.
Import Async. Import As. From MCP, types import content block. From OpenAI, import OpenAI. From FastMCP, import FastMCP. From FastMCP, experimental, sampling, handlers. OpenAI, import OpenAI sampling handler. From FastMCP server context, import context. Async def async main. Server equals FastMCP. Name equals OpenAI sampling fallback example. Sampling handler equals OpenAI sampling handler. Default model equals GPT-4o mini. Client equals OpenAI. API key equals OS getenv API key. Base URL equals OS getenv base URL. Sampling handler behavior equals fallback hash default. Only use when client doesn't support sampling. At server tool. Async def test sample fallback CTX context content block. Hash will use client's LLM if available, otherwise falls back to the handler. Return await CTX sample. Messages equals hello world. Await server run HTTP async. If name equals main. Asyncio run async main.
This demonstrates the fallback handler pattern for LLM sampling in distributed systems. The code shows how to implement a dual-layer sampling strategy, where requests first attempt to use the client's LLM, but automatically fall back to a server-side handler when client capabilities are insufficient. What makes this distinctive is the transparent failover mechanism that maintains consistent behavior regardless of client support. The pattern works through a hierarchical delegation model. Sampling requests flow through a priority chain. Client LLM first, then server-side handler, with the behavior controlled by a single configuration flag. This creates a clean separation between the sampling interface, what tools use, and the implementation strategy, how requests get fulfilled, allowing tools to remain agnostic about the actual LLM provider. This approach solves the common problem of inconsistent LLM capabilities across clients. It enables tools to reliably use LLM features without requiring every client to implement sampling support, while still allowing advanced clients to use their preferred models. The trade-off is slightly increased server complexity in exchange for dramatically improved client compatibility and developer experience. Let's break it down.
Import Asyncio. Import As.
Imports Asyncio for async await support, required since FastMCP uses async I/O for concurrent tool execution. Also imports As to access environment variables, which we'll use for API keys and configuration.
From MCP, types import content block. From OpenAI, import OpenAI.
These imports establish the core types for AI interaction and OpenAI integration. Content block defines the standardized message format between tools and AI models, while OpenAI provides the official client for API calls. Both are essential for the sampling fallback mechanism to work.
From FastMCP, import FastMCP. From FastMCP, experimental, sampling, handlers. OpenAI, import OpenAI sampling handler. From FastMCP server context, import context.
These imports establish the core FastMCP components. FastMCP is the server class that exposes Python functions as AI callable tools. OpenAI sampling handler provides the LLM fallback mechanism for sampling operations, and context is the required parameter for all FastMCP tools that handles logging, progress reporting, and sampling requests. This is the standard setup pattern for any FastMCP server implementation.
Async def async main. Server equals FastMCP. Name equals OpenAI sampling fallback example.
This defines the async entry point for the FastMCP server. The async main function initializes the server instance with a descriptive name, which helps with logging and debugging in production. The name parameter follows FastMCP's convention for identifying server instances, particularly useful when running multiple services.
At server tool. Async def test sample fallback CTX. Context. Content block. Hash will use client's LLM if available, otherwise falls back to the handler. Return await CTX. Sample. Messages equals hello world.
This defines an AI callable tool using FastMCP's decorator pattern. The function demonstrates sampling fallback behavior. It first attempts to use the client's built-in LLM, but automatically falls back to the configured OpenAI handler if the client doesn't support sampling. The context parameter provides the sampling interface and handles the fallback logic transparently.
Await server. Run HTTP async.
This starts the FastMCP HTTP server asynchronously. It blocks until shutdown, handling all incoming AI tool requests through the routes you've defined. The async variant enables concurrent request processing without thread overhead.
If name equals main. Asyncio. Run async main.
This is Python's standard entry point guard. It ensures async main only executes when the script runs directly, not when imported as a module. The asyncio run call starts the async event loop and executes the server setup. Sampling fallback pattern. The sampling handler behavior parameter in FastMCP2 defines whether the server delegates sampling to the client or handles it internally, with fallback as the default and always for complete server control. The client must explicitly support sampling, or the server must configure a fallback handler, otherwise CTX. Sample will raise an error. This pattern enables flexible LLM integration while maintaining backward compatibility with clients that don't support sampling.
The handler that never speaks becomes the voice of every silent client.